Welcome to the Programming Basics chapter. This chapter will introduce you to the fundamental concepts of programming, data structures and algorithms, and object-oriented programming. By the end of this chapter, you should have a solid understanding of these core topics that are essential for any computer engineer. Programming is the process of designing and building an executable computer program to accomplish a specific computing task. Let's dive into some key concepts. Programming languages are formal languages comprising a set of instructions that produce various kinds of output. Examples include Python, Java, C++, and JavaScript. Syntax refers to the set of rules that defines the combinations of symbols that are considered to be correctly structured programs in a language. Semantics, on the other hand, deals with the meaning of these syntactically correct strings. Here is a simple example in Python. The code print open parenthesis quote hello world exclamation mark quote close parenthesis will output the text hello world to the screen. Variables are used to store data, and data types specify the kind of data a variable can hold. Common data types include integer for whole numbers, float for decimal numbers, string for text, and Boolean for true or false values. Here's an example of variables in Python. The variable age is an integer with a value of 20. The variable height is a float with a value of 5.9. The variable name is a string with the value Alice, and the variable isStudent is a Boolean with the value true. Data structures and algorithms are fundamental to efficient programming. Data structures are ways of organizing and storing data so that they can be accessed and modified efficiently. Algorithms are step-by-step procedures or formulas for solving a problem. Common data structures include arrays, which are collections of elements identified by index. Linked lists are linear collections of data elements where the linear order is not given by their physical placement in memory. Stacks support push and pop operations, while queues support enqueue and dequeue operations. Trees are hierarchical structures with a root value and subtrees of children with a parent node. Graphs are collections of nodes connected by edges. Here's an example of an array in Python. The code numbers equals open bracket 1, 2, 3, 4, 5, close bracket creates an array. The code print open parenthesis numbers open bracket 0, close parenthesis will output the first element, which is 1. Algorithms are step-by-step procedures or formulas for solving a problem. Key concepts include time complexity, which is a measure of the amount of time an algorithm takes to complete as a function of the length of the input, and space complexity, which is a measure of the amount of memory an algorithm uses as a function of the length of the input. Bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. Here is the code for the bubble sort algorithm in Python. The function bubble sort takes an array as input. It iterates through the list, comparing adjacent elements and swapping them if they are in the wrong order. The sorted array is then returned. For example, sorting the array 64, 34, 25, 12, 22, 11, 90 will result in the sorted array 11, 12, 22, 25, 34, 64, 90. Object-oriented programming, or OOP, is a programming paradigm based on the concept of objects, which can contain data and code to manipulate that data. Key concepts in object-oriented programming include classes and objects, where a class is a blueprint for creating objects, and an object is an instance of a class. Encapsulation is the bundling of data with the methods that operate on that data. Inheritance allows one class to inherit the attributes and methods of another class. Polymorphism is the ability to present the same interface for different data types. Here is an example of a class in Python. The class dog has an initializer method that sets the name and age of the dog. It also has a method bark that returns a string with the dog's name and the word woof. Creating an object of the dog class with the name Buddy and age 3 and calling the bark method will output Buddy says woof. Here is an example of inheritance in Python. The class animal has an initializer method that sets the name and an abstract method speak. The class dog inherits from animal and implements the speak method to return the dog's name and the word woof. The class cat also inherits from animal and implements the speak method to return the cat's name and the word meow. Creating objects of the dog and cat classes and calling their speak methods will output Buddy says woof and Whiskers says meow, respectively. This chapter has provided an overview of the basics of programming, including an introduction to programming languages, data structures and algorithms, and object-oriented programming. These foundational concepts are crucial for your journey in computer engineering. Continue practicing and exploring these topics to build a strong understanding and proficiency in programming.